Mr. Gartzounis.
Thank you.
No.
Thank you very much. This is a room for the heart operation, right? No? Wrong room. Dear delegates, thank you for coming to this amazing conference. It was a pleasure to me, certainly, and I think my presentation will just recap the whole thing for the 3 days we had. I think I'm keeping you from having a perfect rest of the day, near by the pool, so I try to make this as concise and timely as I can. Okay, have a look at this. This is the title of my presentation. And while you're checking the quick overview, I will try to explain the scope and the whys behind it. And if you're involved in the healthcare facilities design, you know that there is a lot to take into consideration, and we saw that. And the slides are structured from a soft to a hard reasoning. So we start with the title, No Typical Design. This graphic shows that the healthcare ecosystem is amazing, and for this industry we identify the complexity, the vastness, the engineering overlaps, and the specifications required per medical and patient need. This image also shows the increased and demanding interaction of engineering and medical spheres. Healthcare buildings are important for modern societies, and they are important as Hippocrates' legacy coming from the 460 BC. Their critical role is a decisive criterion of a successful modern state, and to get the idea of how serious this can be for our societies, we can weigh this business over money and energy numbers. Healthcare buildings represent an estimate of 700 terawatt hours per year and nearly 2.3% of global energy demand. It might sound low, but it isn't. And this is due to 24/7 operation demand for ventilation, heating, cooling, hot water needs, and also continuous operation of labs, clinical equipment, and sterilization units. Global healthcare buildings represent an investment market of roughly $300 billion per year. And when a wider health capital investment is included, that is infrastructure and capital assets, the scale approaches around $400 billion per year, with hospitals receiving the largest share. So what is under consideration? What is our scope and case? In 2 words, we have to look at clinical consequences. For healthcare buildings, we come across strings of words such as incompetence, misconduct, inefficiency, inappropriacy, breakdowns, setbacks, errors, flows, oversights. My God, no end to this. And all these lead to bad practice, bad design, system failures, deficiencies. Not resilient, certainly not efficient design. Right down there, what it says is a 10 trillion global healthcare sector, 10 trillion US dollars global healthcare sector that cannot rely on unverified buildings performance. In healthcare facilities, engineering failures become clinical, operational, and financial risks. So for doctors, the practical question is whether the room environment protects the patient, the staff, and the sterile field. But for engineers, the question obviously is whether the system can prove that it performs correctly in all realistic modes, including occupied use, unoccupied setback, emergency operation, maintenance, seasonal extremes, and partial loads. A little history now, Greek history. So, in the Greek state, the available healthcare system has divisions, levels, as we call it, of public health. It is a pyramid from first degree to the third degree organization, and is a strong combination of public and private system. Now, between 50s and 83s, Greece gradually built its hospital infrastructure from minimal base, and the post-war period saw the construction of the first organized public hospitals, primarily concentrated in Athens and Thessaloniki, leaving rural areas severely underserved. Hospital buildings were often outdated, overcrowded, and poorly occupied. Medical technology lagged behind Western European standards. Regional hospitals in smaller cities were inadequate, forcing persons to travel to urban centers for specialist care. And then the national health system came in 1983. And in that time, we have a turning point. 3 new university hospitals are assigned for construction in 3 major cities in Greece. And for the first 2, I don't have actually for the Rio construction, but for Iraklio and Ioannina, there is a consortium of a German company, Philip Holtzmann AG, and the Panon. I cannot find, well, that's the point is the construction is that this university come with 2 important elements to the healthcare facilities case. First is the advanced hospital designs with many new installation types, like labs and research facilities, close to modern European standards of that time, brought the technologies such as fan coil units, all air units with 100% fresh air for operation rooms or operation theaters, also introducing increased electrical demands and high-risk installations for medical gases, fire protection systems, incinerators, etc., etc. And the second point was specifications were added to the healthcare facilities absent until then. Now, I mentioned a Greek company, the Panon. We had a young engineer at that time, passionate, I guess, with his team, surname as Dr. Ballas, Dimitris Ballas. What he does is he gathers construction and implementation problems from around these 3 hospitals, mostly, and then he writes the first national guidelines for hospitals. That is mostly the basis of what we use today in hospital design. So I mentioned actually bad practice and bad design, system failures, deficiencies. Are these things noticed by the stakeholders? After 3 days, I guess they are. And in our job, in design job, and what we do in Greece, yes, we all talk together, and we know that the current situation has pluses and minuses. I'm not sure if you can read this for the pluses and minuses there, so I'm just going to read it out for you. So the good things is that after that time, we had good practices that remain to modern plans. Say 100% fresh air, very nice. For operation rooms, we had increased attention to engineering hospital zones, excellent. And highly demanded areas according to doctors' work or patients' needs, or specialized requirements for different departments. Another plus is independent autonomous systems and fail-safe installations to a good extent. Now the bad. Very complex designs, hard to implement, maintain, and operate. Lack of renewable technologies to utilize, lack of experienced and trained maintenance personnel, increased energy use, no operational systems feedback, non-resilience to deal with the sudden virus outbreaks, pandemic incidents like COVID-19, or major climatic change risks, or even a war-like compensation. Admiral, I don't know if you hear, he knows about that. And various disappointing facts for these buildings from simple events, such as stray animals coming inside the hospital, the healthcare facilities, to problematic run and operational deficiencies, like say repeal the clean or aseptic corridors, routine with that of contaminated corridors. That is word of mouth. That is what we know talking to one another. What about the rest of the world? Well, we have so many invitees from all your countries, more or less the last 3 days. You set it out. Yeah, we get a picture, similar problems. I just looked over YouTube for this specific topic, and I'm just going to read out some keywords relating to this from our colleagues around the world. Like Ontario Association of Architects, they had this conversation on building wellness and how hospital design impacts health and community. Some keywords there: design choices significantly impact the long-term public costs and environmental footprint of these essential civic hubs, or hospitals are technically demanding and strictly regulated. Their core purpose is to serve as resilient community anchors. ASHRAE had another topic on HVAC system design for sustainability in healthcare facilities. Keywords there: critical intersection of healthcare infrastructure and environmental sustainability, advanced HVAC design strategies. You get the idea. Okay, Industry 4. In US, there's firm interface engineering. They talked about healthcare design in an era of constraint. They examined reshaping healthcare design, long-term operational resilience, and fiscal health. It's more or less the same questions that we have. Oh, problems with the page. So, we said at the beginning that this deal, that what we deal with is no typical design when it comes to healthcare buildings, and with your presentations we realized that throughout the 3 days conference. Hospitals, clinics, laboratories, sterile areas, diagnostic departments, isolation rooms, and operating theaters depend on engineering systems that directly influence infection control, clinical continuity, staff safety, patient comfort, energy use, and resilience. How to translate on that? Obviously through ASHRAE. For this demanding industry, we found that the core of ASHRAE's work is there. We have fantastic texts and work in this field that can become a strong baseline for engineers. And that was my drive in the first place to make this presentation. And all of us in this room has proven me right. This is ASHRAE's backbone: technical committees. They are the true engine, and we know that, of the global HVAC design and infrastructure in the healthcare industry. Back to slide 5 now. I said about system failures and deficiencies. And this can be actually classified in 8 failure families, if you like. The last column, sorry, I'm ahead. It's okay. Move forward.
5 minutes, please.
Really? Time does fly. Okay. I leave the wheel of misfortune. I won't read some stuff there. Let's concentrate to 4 cases then. 4 problematic cases. Just have a look at that. Let's try to find. I made a mess of my slides. Jesus. Okay. Very awkward. Okay. Thank you. I'll buy you a beer after that. Now, so far we have identified that the healthcare buildings may carry a lot of sensitive design anomalies, but they lead to risk and bad operation. In these slides, in these 4 slides, we're going to go from the problem to the solution through ASHRAE standards and guideline. Most of that, you can look it up yourself. I can send it out, any information you want after this. Key points here is that operating rooms are the strongest open case because doctors understand the consequences immediately. An operating room can look modern and still fail if pressure, overflow direction, temperature, humidity filtration, door discipline and controls when they do not work properly. And air changes per hour, high air changes per hour won't save the situation. That is not safety. Isolation rooms and protective environments. Well, they are useful, these cases are useful for explaining the difference between design, intent, and measured operation. A negative pressure room protects the outside environment from an infectious source. A positive pressure protective environment protects an immunocompromised patient from the surrounding environment. Both can fail if leakage, controls, door operation, and alarm response are not managed. Gonna leave some stuff out because the panel here is gonna keep me alive. Then we have the laboratories, humidity and water systems. Most of what we have examined the last 3 days. Laboratories, no simple support spaces. They may include chemical exposure, biological risk, odor, pressure balance, fume exhaust, high loads, and staff safety requirements. Same with humidity and temperature failures. Easy for doctors to understand because they connect directly to surgery delays, sterile supply integrity, comfort, and complaints. They're also a useful way to show that controls and commissioning matter as much as equipment selection. Controls and BMS, you said it, all of that case was analyzed in the previous days. Controls issues often where good design intent becomes poor operation. In many healthcare systems, the BMS record comfort data does not prove clinical safety conditions. Critical rooms may have pressure sensors, but no useful trends. Alarm may exist, but no one owes a response. Energy optimization may reduce airflow or humidity control without verifying clinical readiness. I'm not going to stand for the commissioning because that topic was analyzed by fellow colleagues. So these cases, And the comparison of bad and good reality takes us to the operation of the healthcare facilities, what we call resilient governance. So governance means that the hospital can prove that critical environment conditions are designed, tested, monitored, maintained and corrected all the time. This is a practical governance and not administrative language. Resilient governance assigns ownership before the failure occurs. You can see that matrix there. Recurring pressure, humidity, or alarm failure is not only it's not only facilities issues. It's in a healthcare building. It's a clinical risk signal. Again, the matrix implies resilient governance assigns ownership before the failure occurs. Now I have to run through.
2 minutes, please.
Yes. Okay. Justification. I had to see if all what I have done, the texting, could be justified from real cases. What is real case? Open data, healthcare databases. So my aim there was to identify if healthcare buildings provide available data, open for evaluation and analysis, discover the format and accessibility of these databases, discover data continuity and spread, and obviously approach the quality coherence for some reasonable results. So I did find some, mostly from the UK, but you can see there are other situations. And after some screening and some data processing, you can see that the best classification and sensitive findings show that most of the cases examined says act now, and most of them also is investigate that something goes wrong. I'm not going to go into details, you can find the link for that. More databases, same situation, running over, more problems. Conclusions. I just want to stay to the healthiness of ASHRAE and the medical environment. We've seen the last 3 days how important it is for both worlds to come together. And I think I'm not going to read that out. I mean, you can certainly understand what's going on. And certainly the looks of David Bowers and his expression is just saying, okay, take the next day with you. And I will stay to the connect doctors, engineers, client administrators, and officials early, and use ASHRAE as a common technical language for what we have discussed, and take it further for the next day. That's it. Pool is now available.
Thank you very much, Mr. Gartzounis. Do we have any questions for Mr. Gartzounis? In the meantime, please fill the last questions on the Slido to conclude with our presenters.
They want to do.
You have been very thorough. Everybody understood everything.
Yeah, I'm sure.
Thank you so much, Mr. Gartzounis.
Thank you very much.